And so the thing that I landed on was over the next decade, I think that the best engineers are going to specialize and vertically integrate the components of their application. And there isn't a stack that does that today. Like if you want to swap out parts of the P2P, parts of the consensus, add additional mechanisms, like that doesn't exist. And so when I was thinking about doing something, supporting that group of developers was a pretty exciting thing to me because what I'm working on is I want blockchain to actually get the adoption that we all think that it could, or that the power that it has to be so prevalent in the world around us. But I think that the way that happens is best when you basically need to extract additional performance that you can't get from the traditional framework style approach.
None of the information in this podcast constitutes investment advice or an offer, recommendation, or solicitation by WAGMI Ventures or any of its affiliates to buy or sell any securities. Hey WAGMI family, Benga here with another WAGMI Ventures podcast episode. Today I'm chatting with Patrick O'Grady. He's the founder CEO of Commonware. Commonware is an open source, anti-framework set of primitives that developers can use to build and reassemble their applications without resorting to a complicated fork. Basically, they're the best verticalized stack for building blockchain applications out there. For anyone who is new, this is the WAGMI Ventures podcast where we do snapshots with interesting builders, founders, and investors across crypto and AI. Check out wagmiventures.io to learn more about the syndicate behind the podcast. My man Patrick's on. Let's get at it. Welcome. Thanks for joining us today.
Yeah, thanks for having me. Really excited to talk about Commonware and some of the conversations we're starting to have with developers that are using it.
Cool. Sounds good, man. We'll jump right into it here with you sharing your journey in crypto leading up to founding Commonware. You could talk also about like how, maybe your time at Ava Labs and other roles may have influenced your decision to start.
Yeah. I grew up far away from all of this in the Midwest, in Wisconsin in particular. Let's just say there wasn't a lot of crypto going on there. So I got into it actually when I came out to the Bay Area for school. And got totally, basically not that it affected me much at all, but like during the summer when Greece was having a currency crisis and people couldn't withdraw their money from the bank, I saw this article about how people could instead use, if they had Bitcoin, withdraw as many euros as they wanted. And immediately it resonated to me what the whole point of all this was, at least from the beginning. And so I took all the money I had, put it into Bitcoin, and then the price went up 20%, sold everything. And that was a huge mistake. But got into it originally at that point. And then after school, worked at Coinbase for a year and 9 months or so. I worked on a project called Rosetta there. Which is a universal interface for reading and writing to blockchains made to make asset integration faster and more reliable. And then after that, in January of 2021, I joined Ava Labs as an engineer. And then a month later or so was promoted to head of engineering and then grew the engineering team there to about 95 or so folks. So it's been a bit of a whirlwind. It's been fun to watch the space evolve over the years, and there's just so many more great people in it now than there ever were. And so it's been fun to collaborate with them and talk about them with all their latest and greatest ideas of how to really bring blockchain to the average person. And I think the meme for so long has been, yeah, you have a blockchain, but now what? And I think we're now starting to get to a window of performance on a lot of these systems that can actually be used to create really unique products that can actually compete with their Web 2 counterparts. And so it's a really, I think, exciting time to be in the space. And yeah, it's been fun to see that evolution over the years and understand all the mechanisms that made it come to be. So that's my brief interlude. I'll dive into it.
Yeah, brief, but very insightful there. I think you've seen a few iterations of things in the space and how things have evolved. I mean, your time at Coinbase and Ava Labs, you would have definitely had a lot of exposure to the challenges you see in this space today. Is that sort of was the motivation for creating the anti-framework?
So yeah, I mean, I wouldn't say one day I woke up 2017, I was like, you know what we need? The anti-Commonware or anything like that. So right. What ended up happening is I joined Coinbase because I was a big believer in what this technology would do, but I didn't feel like I had a strong enough conviction on the particular way that it would actually make a big impact. And I figured, this is 2019. It was like a deep bear market. And I figured if anything crazy happens here, Coinbase is going to have some role to play. So I figured I could go there and at least work for a credible, really solid engineering organization. And so through my time there, I got to spend a meaningful amount of time with people actually working with Coinbase to integrate, and started to develop a much stronger sense of what I thought was the best architecture for application developers. And so by the time I was starting to think about working actually in the protocol component rather than on the integration side, what really was resonating with me was this idea that there would be many chains. I mean, in the world today, people don't agree on anything. And I don't think that blockchains are going to be the first place where that happens. And so I figured, great, I think there's going to be a lot of chains. That the first thing that's going to come up is how do you actually connect these chains together? And then the development experience, at least at that time, was, even now, is still so EVM heavy. So is there something that like really takes all of those considerations into account? And that's when I actually stumbled onto Avalanche, of which I was actually Kevin from Avalabs reached out over Twitter. I was like, hey, you heard of Avalanche? And I was like, yeah, I have. Actually, I'd love to love to learn even more. And so when I went there, that was my guiding light. And so the big benefit there being that Avalanche Consensus was unique in its capability. And if you're going to have integrated messaging using more of a relay architecture rather than like point-to-point connections between everybody, or like having some sort of registry where like all participants are kept, you want to have a ton of validators there. And so Avalanche Consensus was really uniquely positioned, I think, to support that architecture. And so had a blast there. We built some amazing stuff. There's some really strong technical talent there, which I particularly really enjoyed working with. And over the years, we shipped a lot of major components to make all of that capability possible. But basically around midway of last year, I was starting to, it's crazy that it's already been 7 or 8 months into the Commonware story, but I was thinking, or as I was talking to different application developers and really thinking around what the next decade was going to look like for people building in blockchain, what became pretty clear to me was that the abstractions and interfaces that most people were building with today were just not getting the job done. And so if you talk to people that have built on existing frameworks or different ways that they've forked things to bring their application to life, and you ask them, what do you think about that? Are you a big fan of what you did? You think other people should do it? And let's just say you're not going to get a positive response from that question. And so anytime that happens, it's either A, the problem's really hard and it's just not a tractable thing to solve, or B, we should rethink some of the abstractions with new knowledge. And so the thing that I landed on was, over the next decade, I think that the best engineers are going to specialize and vertically integrate the components of their application. And there isn't a stack that does that today. Like if you want to swap out parts of the P2P, parts of the consensus, add additional mechanisms, like that doesn't exist. And so when I was thinking about doing something, supporting that group of developers was a pretty exciting thing to me, because what I'm working on is I want blockchain to actually get the adoption that we all think that it could, or that the power that it has to be so prevalent in the world around us. But I think that the way that happens is best when you basically need to extract additional performance that you can't get from the traditional framework style approach. And so with Commonware, the idea was, let's build a bunch of little pieces that work really well independently, and then give people ways to pull them together into different applications and remix them with their own renditions of some of those primitives, or to create their own primitives. And so, yeah, we've built, I think, I don't know, it's something like 9 or so, maybe 7 different primitives now. And it's been really fun to see the response we've gotten from application developers who have wondered, finally, this sort of thing exists. Like, where has this been for so long? So I can talk a bit more about how that came to be, and also how it compares with what I think is out there today.
Yeah, no, would love to hear more on that. I think just picking up the different pieces of what you need for your own specific application certainly makes sense conceptually. And I think it ties nicely into the best verticalized stack, like for building blockchain apps. What does that mean, bud?
Yeah, that's it's a mouthful for sure. Yeah, we're definitely letting all the GPTs do the heavy lifting on translating some of our marketing into things that actually sound right. Yeah, I mean, so the idea is that the way that we've been building for the last 10 years or so has been very framework and interface driven. So modeled predominantly by like the operating system approach, where you have like a monolithic interface that basically manages access to different underlying resources, and then your application is on top of that, and you deploy or like tailor it for this interface that's exposed by, what we'll call like the kernel abstraction. The problem is that blockchains are not operating systems and they're not kernels. And so the idea of applying them, or the same concept, is rooted in some sort of insight in that, well, it worked really well for operating systems and applications, right? Like you don't run Excel OS, you run, a general purpose operating system, and people deploy applications to it. The problem is that this is a different environment, and we have seen that this runs into some limitations of what's actually possible, given how diverse people's deployment approaches are. Whether you're a standalone network, an L2, an AVS, you name it. Like there's a lot of different pieces going on here, and they definitely don't look the same. And it's really tough to balance the resource abstraction that way, but also these mechanisms, at least in the operating system world, were generic, but always better than the required performance of the application. Or usually there may be periods where it wasn't quite the case, but today most people would say it'd be crazy to develop your own operating system, and it's pretty much good enough the way it exists. However, in crypto, like if you model like resources like a mempool and consensus and state, there are huge differences between how you could actually instantiate those, and they're very rapidly evolving. And so the idea that you're going to select one approach, tie yourself strictly to that, and then offer a very minimal interface to the application is a great idea at the beginning, helps you get up to speed really, really quick. But as soon as you actually want to create a differentiated experience, it gets really hard to modify, because there's so many tight and strong assumptions between the different components. And so what we have talked to a lot of people about is great. Anyone can spin up a blockchain today on any number of stacks and frameworks. But then when you say, yeah, but now add that special component that makes your application unique, you get a lot of blank stares, because it's just not something that they've talked to people that have forked stuff and they're terrified, or they don't even know where to start because the whole system is so tightly intertwined. And so we think that this applications really can achieve differentiation through this specialization, and differentiation is what I think creates sustained businesses and sustained communities. If you don't have differentiation, you just get a lot of value hopping between different ecosystems. Mm-hmm. And the clearest way to like have lasting success is to be better at something than anyone else can be. And if you have deep differentiation in the way that your application works, all the way down to the P2P layer, you can do things that no one else can, because you have special mechanisms designed for exactly what you meant to do. Whereas in the general purpose case, it's like, all right, someone deploys a new contract with a new interface. It's like, well, time to move the money over there because it's a better return or something. And so if you want to really have a sustained business, I'm not sure there's another route. At least, well, the last one that works over the last 30 years is this exactly. So maybe blockchain will be different in that regard. But we come from the belief that the best applications must specialize at a much deeper level if they want to have any staying power over the next decade. And so we're here for that.
No, I think conceptually it makes a ton of sense. And you're already seeing folks responsive to the approach, because it saves a lot of time and it's just more efficient, because it's not a one-size-fit-all approach to developing the stack. And I think one of the other things that comes to mind is how all the key components of Commonware come together. And so whether it's cryptography, peer-to-peer communication, and consensus mechanisms, would like you to unpack your thoughts on how these components integrate and support robust blockchain solutions.
Yeah, we definitely use a lot of words, and it's easier to just look at the code in some sense. So fortunately, the Commonware library, which is our main effort, is all publicly accessible, and it's open source to MIT Apache 2. There's no license agreement, and there's no like license fee or anything like that, and there's no ecosystem alliance or anything. So you can just use whatever the code is, however you want. How it works is because a common question we get is, cool, so what are you built on? expecting us to say some sort of ecosystem or chain or whatever. We are built on TCP and the kernel, really, the actual operating system that you're running the software on. So we do not have any ecosystem specific dependency. And so the way that the stack works is you have, which is not a runtime as in like an execution environment like the EVM. It's actually like how you actually orchestrate asynchronous tasks and store and track metrics and interact with the raw network. On top of that, we have P2P. So people, maybe that word sounds familiar, which is a mechanism for peers that are authenticated with some sort of custom or user provided cryptography to connect and discover each other. Then on top of that, we have consensus, which is, we have two variants. One is a non-threshold simplex, and then one is threshold simplex. That works just like any other consensus mechanism. You come to agreement over some opaque set of messages. The big difference is that the consensus knows nothing about your application. So you can just put a digest inside of it and it will come to agreement on it. So for people that are working on really interesting execution environments, this is a great fit because all you have to do is give us some sort of digest of or hash of what your application does, and then everything else just works. We have storage, which is storing arbitrary data, and that can be proved. Right now, we're pretty heavy on the Merkle Mountain Range side, but are working on a mutable store. And then a bunch of other little mechanisms that fill in the gaps. So like, you want to pull data from a network of participants by a fixed length key. You want to perform some sort of like authenticated broadcast or reliable broadcast to a set of participants. And then we have a set of examples as well. So in a nutshell, what I would say is if you were to build a blockchain from scratch, most people today would or not from scratch, but build a blockchain. Most people would take the Cosmos SDK and write some application logic on top. The best way to think about the Commonware library is if all the primitives that were inside of the Cosmos SDK were actually standalone pieces that you could choose to select or not select or replace at your heart's content. And so we are working towards an example that is a full blockchain instantiation that runs all these pieces together to give people a really clear idea of just how you actually pull it all together, and that this is not just a set of random things, but very much intended to be useful for building blockchain applications today.
Hey everybody, quick thing here. We're excited to announce WAGMI Advisory, your home for all things fundraising, hiring, and partnerships. This is all about supercharging your project with the WAGMI network, consisting of over 20,000 executives, investors, and builders in crypto, all ready to come alongside your project to help it succeed. Get in touch at team@wagmiventures.io to learn more and figure out if WAGMI Advisory is the right fit for your project. Let's get back to the show. Brilliant. How do you think that all fits into your emphasis on modularity? Does this design philosophy impact the scalability and adaptability of blockchain applications?
So, yeah, I mean, the whole monolithic thing is whole thing in crypto, and then there's actual software. So we're talking about software modularity here. Now, traditionally, when you see a blockchain project come up, you usually become some sort of maxi of some particular mechanism, right? So it's you designed your own consensus and that's your big thing, or you have some sort of storage thing and that's your unique and special thing. We are not maximalists on a particular mechanism. We don't say, if this cryptography isn't used, you have no idea what you're talking about. We are very open to the idea of creative destruction when it comes to technical primitives. And so the focus on modularity is really useful for building custom applications we didn't have in mind that you would be creating with this stuff, which we've already seen some people start to play with. Project won the ETH Denver hackathon using Commonware to build this gas scaling mechanism using an AVS, which was really cool. Not something I would have thought I was going to build at some point. So it was cool. This is exactly what we want to see, is people just taking the primitives, adding some of their own logic, and then creating really cool things. And so, but what that means for Commonware is we know this stuff is moving really fast. And so if you enshrine certain primitives, you're going to be stuck on those primitives. And so there's a few things coming up on the horizon, whether that be really fast Stark and Snark proving and verification or quantum safe signatures. The way that we're designing the architecture is that if you want to care about those things today, you can just bring in those components and implement things and then use all the other mechanisms without having to fork the whole thing. So for us, it's a way to say, we know this stuff's going to be really rapidly evolving. How do you actually handle that? Do you try to create some best ever and then hope nothing ever comes? Or do you expect your best intentions to be replaced by better ideas over time? And we take the latter. And so a lot of the modularity has two really nice benefits, which is, helping applications build what they actually want without maintaining a bunch of code they don't need. And then two, making sure that as the world around us changes, Commonware can continue to be at the forefront of both performance and reliability.
Yeah, it's pretty cool. The project that won the hackathon at East Denver, and it sort of just demonstrates how the primitives can be built on your platform, which I think, again, just kind of speaks to what you guys are trying to accomplish here. So when you think of like the current limitations of existing blockchain stacks, how does Commonware like specifically address them?
Yeah, so I think it starts. So, I mean, one thing is a developer abstraction, right? So, like people say, oh, that, but if that's all it is, I don't want to say it's vibe coding only at that point, but it's kind of what it becomes. Is, well, we have a better interface, which we think is really important. But I think there's a few other things that are motivating why now with what we're doing. So, the last time anyone really took a solid attempt at building a new stack for launching your own blockchain or like really more custom blockchains was the Cosmos SDK almost 10 years ago. And they've done a fantastic job maintaining it over this time. And like, I think its success speaks for itself. Almost everybody that's doing something custom as like an actual blockchain in production today is running on the Cosmos SDK or some variant of it that they forked away. That's impressive. Yeah, extremely so. And if you don't think so, you should take a closer look because that is really, really hard to do. However, over the last 10 years, we've had a lot of different ideas for how to scale things. New cryptographies come out, all these different things that if they existed today would be great. So we're at Commonware at least very interested in decoupled state machine replication, which basically means broadcasting transactions reliably through the network prior to their ordering and execution. Now, this, if it doesn't sound or if you have no idea what I'm talking about, that's okay. All you need to know is that adding that capability into an existing stack is not something you can just slap on. It is a very deep rethink of how the components fit together.
But does it necessarily make things faster, or what is the aim of
it dramatically increases the throughput and of the network itself. So like instead of having a leader reliably broadcast transactions through the network, all validators can concurrently broadcast transactions. So it much more effectively utilizes the resources of each participant in consensus to drive much higher throughput with the same resource usage or like basically the same resource allocation per participant. So this is a new concept. Well, it's newly rediscovered, I should say. The original idea for decoupled state machine replication shortly followed PBFT as specification and, I think I might have the order there wrong, but long story short, the DSMR kind of was originally ideated on in the early 2000s and then wasn't ever actually practically utilized until the Narwhal Tusk paper in the late 2010s from the Libra effort. And that really rediscovered and brought some of these ideas to the forefront. And the only blockchains that are using that concept really deeply are Aptos and Sui, I believe, with others potentially considering it. But there are deep changes required to actually deploy DSMR in a real network and protect it and make sure it doesn't open up any gnarly DOS vulnerabilities. And the second is the proliferation of threshold signatures. So particularly BLS 12 381 threshold signatures are much, much faster than they used to be. And so if you combine both of those unique changes in the landscape, we think that the door opens for a new project to employ those from the get-go and to really provide a unique performance and unique capability for applications that are actually launching in 2025. So a lot of what we're doing is about commercializing and really productionizing a lot of these newer techniques that have not yet been widely adopted, and because they've typically been closely tied to some sort of ecosystem. And so instead with Commonware, the whole idea is that we can commoditize all of the performance capabilities that you might want in like a differentiated application. So you can, as an application, retain leverage as the one making these decisions rather than being part of an ecosystem where the technology is provided to you by proxy. So we just think there's a room for technical delineation, basically, that you as an application should build what you think is best and then join an ecosystem that suits you for the right reasons rather than because they're the only ones with the best technology.
And in creating that technical delineation, what has been like the most significant challenges you've faced, and how have you guys overcome them?
Yeah, so the biggest thing is like we have this list of primitives that we think are really awesome. And then people are like, so it's a list of primitives, now what? And so we've been working on some cool experiments and examples and different sorts of design partnerships that showcase how you actually turn the primitives into an actual thing. Because people are used to looking at it from the lens of, how do I deploy my application? Let me just deploy code here and then I'm good to go. Whereas this requires a little bit more assembly. We think you're going to, after you get past that step, really enjoy the flexibility you retain, but there's definitely more steps, more assembly required. And so the biggest challenge has been getting people to, one, understand that assembly process, and then two, naturally, like blockchain is a pretty obviously security intensive industry. And so anytime a new thing comes up, it doesn't matter how good it is, if people don't feel like it has proved its worth in production in like an adversarial environment, you're pretty terrified to actually launch some application on it. And so we're working on all sorts of different security procedures and mechanisms to ensure folks that are building on us that this is a really production ready thing. And so we're going to what we think are great lengths to provide that sort of assurance with deterministic simulation and working with hopefully best-in-class security researchers on securing everything that we're doing. But I'd say those are the two. Is there's a lot of pieces here. Imagine someone hands you a bucket of Legos with no manual. What are you going to build? And it's like, you're used to following some instructions and having a car, right? Well, you could also build a house. You could build a boat. Like, it's up to you to figure out how to pull those together. And then, secondly is, this is new and very open about that. How do we ensure that people that use it doesn't just crash on day one or like it's trivial to attack? And so we're trying to think deeply about both of those areas.
It's pretty cool. I would like to hear more on upcoming projects or developments at Commonware that you're particularly excited about. I like your analogy of being thrown like a bucket of Legos. So
I came up with that just now, so that worked out. Yeah.
Yeah, no, I mean that's essentially what Commonware is, right?
I should have started with that. Yeah.
Yeah. So what projects are using all these Legos to develop new and interesting things, and or what other pieces of the Commonware puzzle are you creating that will help facilitate that?
Yeah, I can't share any names in specific yet, but what we're doing is working on establishing what we call design partners, or a design partner program, basically, where we collaborate with a few different applications that are really excited about building with Commonware to understand what parts are working well and what parts are not working well. And so that may be different functionality, that may be different primitives altogether. We're not a developer shop, so we don't work with people when they say, "Oh, like build us our application." But we really benefit from being close to people that are building their application and to understand, how usable are all these mechanisms. We certainly have ideas, but it's another thing entirely when you have people actually trying to utilize it and ship it. So the one thing that we're doing on the first point is really trying to find people that are really excited about this and then collaborating with them. And then on the other side, we are shipping our own examples of increasing complexity that showcase what you could do with Commonware. So the next example is a standalone, basically blockchain network that runs across data centers that just runs the consensus. And there's a block explorer basically that you can follow and watch all the consensus decisions fly by at what we think is state-of-the-art performance, both in view latency as well as in finalization latency for consensus construction. And so if you can't see a block explorer, nothing's live. So that's what we're working towards right now, is a link. And then the big difference with ours is, unlike all these other projects that have private repos and private dev nets and whatever, with this, you can actually deploy the whole thing yourself with one command to replicate any of our results. So we think that there's this transparency that has started to go the other way in crypto, and people have started to use it, use crypto for some of its not strong suits, and instead just market on the name of blockchain. And so we want to return things back to this mandatory build for everyone with opens, primitives, because that's what we think is at the heart of many of the best promises of crypto. And it's not just a new database. And so we are taking as many strides as we can to keep us going in that direction.
Awesome. And in how you're rolling these new use cases out, or is that one vehicle in how you connect with folks? I mean, like, how can folks connect with you and your team, and like where they get started with all this?
Yeah, so we write up in detail, both on our blog and in the code, basically how all of this works. And so with the example we're releasing, we'll release a standalone repository that has everything in it with a lot of documentation on how it all works. And so if you want to get in contact with us, we're going to open up basically a form for people to reach out to talk about this whole design partnership. So far, it's been a lot of Telegram messages and Twitter DMs, actually, to discuss all of these sort of ways to collaborate. And so the best way to get involved if you want to contribute is we're also hiring starting in about a week or so for engineering positions at Commonware. So if any of this sounds interesting to you and you like Rust and you like writing open, this is a great, should hopefully be a fun time for you. And so we're also going to start doing that. So yeah, I would say follow along on the repository, which is all open. And then, we talk about as much as we can on the Commonware website, what we're doing and why to help provide necessary context.
Exciting. So what else in the crypto sphere do you keep an eye on in terms of just general development, investment, or where you see strong promise?
I am entirely focused on two things. One is, plausibly quantum safe cryptography. So like FIPS just finalized the specification for what's called stateless hash-based digital signature algorithm. So it's based on some component of the post-quantum process that they ran. So that is really crazy if we can get that to be a really performant and efficient thing. Right now, the signatures are huge, like multiple kilobytes instead of 30 bytes or something, or 60 bytes like you would see in elliptic curve cryptography. But again, plausibly quantum resistant. So it's good to keep an eye on that if people keep discovering new states of matter. Microsoft said they did. And the other thing is all of the Stark and Snark acceleration, particularly Stark. A lot of the problems in consensus and like a lot of the blockchain stacks today only exist because you can't efficiently determine the truth, like the answer or the result of things. And all of a sudden, if you have really quick Starks and you can just insert them all over the place, it will dramatically change the way that people design blockchain applications from the bottom up. And just like with decoupled state machine replication, are keeping a very close eye on the developments there because we think it will change the architecture of how some of these components work over time. And so I've tried to stay as close as I can on that. Unfortunately, I haven't quite dedicated the time to like fill my brain with the really important parts. I feel like I just haven't had the time to do it, but I'm trying to ingest as much as I can to understand the direction of that system, of those systems, I should say.
Yeah, that handedly has to be one of the most unique answers I've gotten to that question. I think I'm actually going to start looking into that quantum space crypto. I just never really knew it was a thing, like securing data in space. It sounds really exciting.
Well, I mean, yeah, the approach there is basically you have you can use like a lot of the security of hash functions to generate digital signatures. And since we already know, at least we have pretty good ideas around like the security of hash functions, if you just do them in a certain way where you have like your signatures basically reveals of like parts of some sort of Merkle tree, you can do this really cool construction. And because you can't, basically a quantum computer helps you a little bit attack a hash function, but not a lot, not nearly as much as elliptic curve with the discrete log problem. It ends up being a pretty interesting construction. A lot of other people have looked into what's called lattice-based cryptography, which has a whole new set of properties. And so it's a little bit more novel. And the two words you never want to hear together are cryptography and novel. So it is if it works, it could be a more efficient signature construction. Like the signature should be smaller. But the really nice property of these hash-based constructions is that if you use a hash-based proving scheme like you do with Starks, you can start to really get some interesting gains here by some really interesting constructions. So you could have, for example, let's say a signature is massive. Well, if you had a way to actually use a Stark to verify things instead, which is already around the same size, you may be able to justify the size of the hash-based signature scheme pretty quickly with aggregation, or really complex aggregation, because it's verified by a Stark rather than some math over a particular traditional aggregation or threshold signature. So yeah, if you want to work on that, also let us know. But yeah, we are following closely those developments.
Yeah, I almost feel like we're going to have to, have you back on the podcast to just talk specifically about that. But yeah, thanks for your insights there. And thanks for being on the show today, man. Really appreciate you, and we'll stay close.
Appreciate it. Thanks for having me.
Absolutely. Cheers.